Welcome to AmeenAcademy.com. In engineering mechanics regarding friction, let us do one problem. Example, find the force required to move a load of 400 Newton up a rough plane. The force being applied parallel to the plane. The inclination of the plane is such that when the same load is kept on a perfectly smooth plane, inclined at the same angle, a force of 800 Newton applied at an inclination of 30 degree to the plane keeps the same load in equilibrium. Assume coefficient of friction between the rough plane and the load to be equal to 30 degrees. Now let us discuss this problem in two cases. First case, smooth horizontal plane. Here this is a ground, this is an inclined plane, the angle alpha. Here body of 80 Newton, and here inclined on the plane is such that when the force is 80 Newton, not here, this the force applied at an angle theta to the inclined plane, 30 degrees given, 30 degree here, 80 Newton is just keep equilibrium. That means the body should not move, slide downward. And here the find the required force load of 400 Newton. Here this is a 400 Newton. Now let us calculate here the equilibrium. Means here this force is the force required to keep equilibrium is W into sine alpha plus phi over cos theta minus phi. Here this is a, suppose is a frictional force F. Here the surface is smooth, therefore mu equals 0, therefore tan phi also 0. From that angle phi equal to 0. Then apply the value, that is P. We have P is 80 Newton. 80 Newton equal W is 400 into sine alpha over cos theta. Because angle phi is 0 here, then 80 over 400 equal sine alpha over cos theta, that is theta is 30 degrees. Now let us therefore we can say sine alpha equal 80 over 400 into cos 30. Let us calculate first sine alpha, that is 80 into cos 30 over 400 equal sine alpha equal 0.1732 Therefore alpha equal sine inverse of 0.1732, which is equal inverse sine of answer is 9.97. Alpha equal 9.97 degrees. Approximately we can keep it as alpha is 10 degrees. Now consider a rough plane like here. Now we got angle alpha is here 10 degrees. The load will do here, same load of 400 Newton is kept in a rough horizontal plane. Here the force of pulling we have to find. For here the frictional force acting downward. Now we can apply the values here F here, and normal reaction you can put here. Here also normal reaction is here. Now we can solve this. P equal W sine alpha plus phi over cos phi. Here the force is applied horizontally to the surface of inclined plane. Therefore P is equal W sine alpha plus phi over cos phi. Now alpha we know and psi we can calculate. Here mu is given as 0.3, therefore which is equal tan phi. Therefore phi angle is equal tan inverse of 0.3 is 16.7, approximately 16.7 degrees. Now we will put the values in equation, that is P equal W equal 400, W equal to 400 Newton into sine of alpha. Already we have 9, that is 10 degrees, plus coefficient of friction, that is phi angle is 16.7 over cos of phi is 16.7. Let us calculate P equal 400 into sine of 26.7 over cos of 16.7. Let us calculate this value. Here 400 into sine of 26.7 over cos 16.7 equal 187. We equal 187.64 Newton is required to keep the body in equilibrium condition in second case.